Alrighty. So today we are going to review factoring using a greatest common factor, but then we were also going to be talking about our new concept of factoring, or our new way to factor, and that is factoring by grouping, which is exactly like it sounds. Splitting the polynomial into groups to factor. Okay, so on our first few examples, we're just going to do some review. Okay, so let's go ahead and look at number 1. So these guys are binomials, okay, 2 terms, and I need to factor out the greatest common factor, and then it's going to leave me with a factored expression. So the first thing I'm going to do is I'm going to look at my coefficients, -9 and -45. Okay, now, if you remember from last time, we talked about how if my first term has that negative, I'm going to go ahead and just take out that negative. If the first term is negative, go ahead and just take it out. Okay, but now I'm dealing with the numbers 9 and 45. Okay, and I'm not really going to care that that's -45 right now. Okay, so I'm going to go ahead and make my factor trees for 9, or my factor lists for 9 and 45. So for 9, I can do 1 times 9 or 3 times 3. For 45, I can do 1 times 45. I could do 3 times 15. 4 doesn't go into it, or I could do 5 times 9. Okay, well now I just identify my GCF from these lists, and that is going to be 9. So that means I can factor out a -9 from both of these terms. Okay, the second thing you want to do is look at your variables. So my first term has n squared, or n times n. My second term does not have any n's attached. So I cannot factor out any n's since they both don't have them. Okay, so now in my parentheses, I just have to figure out what's left over. Okay, and we figured that out by taking our GCF out in front. In fact, I'm going to make that little note. This is our GCF out in front. Okay, and we're going to take each term and divide by our GCF. So I have -9n squared divided by -9. Okay, well -9 divided by -9 is just going to give me 1. Okay, and since I have that n squared attached, I don't have to put the 1 in front, right? We know that there's an invisible coefficient of 1, so we're good. Now I'm going to take -45 divided by -9, which is going to give me +5. And there we go. There's my factored expression, factoring a binomial using the greatest common factor. Okay, so let's try that again for number 2. So first thing, you want to look at your coefficients. My first term is not negative, so I don't need to pull out a negative, but I'm dealing with the numbers 40 and 15. Okay, so for 40, I could do 1 times 40, 2 times 20, 3 doesn't go into it, 4 times 10, 5 times 8. Okay, so quite a few factor pairs for 40. For 15, I have 1 and 15, and 3 times 5. Okay, so let's go ahead and find our greatest common factor. Okay, and it looks like it's going to be 5. Okay, so I can factor out a 5 from my 2 terms. Okay, now we need to look at our variables. So I have v to the 8th and v to the 7th. So remember, when factoring out the variables, you just have to take the lesser amount, which is 7, right? Out of 8 and 7, 7 is the lesser amount. So I can factor out v to the 7th. Now all we have to do is figure out what's left inside when we divide by our GCF. Okay, so I'm going to divide by my GCF of 5v to the 7th. Okay, so first thing I'm going to look at 40 divided by 5. That's going to give me 8. Then I have 8 v's. I factored out 7. That's going to leave me with 1 v. Okay, now for my second term, divided by 5v to the 7th. -15 divided by 5 is going to give me -3. And v to the 7th divided by, or factoring out 7, will not leave me with any b's. So we are done. Beautiful. Okay, let's look at number 3. Look at your coefficients. So I have negative 20 and 15. Again, that first term is negative. So I'm going to go ahead and take out that negative and now just find my GCF between 20 and 15. 21 times 20, 2 times 10, and 4 times 5. 15, 1 times 15, and 3 times 5. And I can see that my GCF, the biggest number that appears on both of those lists, is 5. So I can take out my 5. Okay, now I look at the variables again. So my first term has an n, my second term does not have an n, so that means I cannot take any n's out. Now all I have to do is figure out what's left inside. Okay, take each term, divide by your GCF. Negative 20n divided by a negative 5. Well, negative 20 divided by negative 5 is positive 4. And then I still have that n attached since we didn't factor it out. Positive 15 divided by negative 5 is negative 3. And there we go. Okay, let's try that one more time. 16 and 12. My first term is not negative. I don't need to take out a negative. I just need to find the GCF for 16 and 12. Okay, 16, I have 1 times 16, 2 times 8, and 4 times 4. For 12, I have 1 times 12, 2 times 6, and 3 times 4. And I can see that my GCF, the biggest one that appears on both of those lists, is 4. So I can factor out a 4 for my GCF. Okay, now look at your variables. I have p to the 7th here and p to the 6th here. Take the smaller amount, which is going to be p to the 6th. Okay, now we just figure out what's left inside when we divide it out. Remember, factoring is just division. That's what this whole process is. So divide by 4p to the 6th. 16 divided by 4 is 4. P to the 7th, dividing out 6 of them will leave me with 1 of them. Negative 12 divided by 4 is negative 3. And then p to the 6th, taking away p to the 6th, will not leave me with any p's. So we are done. Okay, awesome. So those ones are factoring binomials, 2 terms using a GCF. Now what we're going to do is factoring 3 terms, okay? This is what we call a trinomial, 3 terms, or polynomial, where they all have something in common. They do have a GCF, okay? So we are now dealing with 3 terms, 2, 3. The great thing about this one is 2 of those numbers are actually the same. So I only have to make a list for 24 and 40. Okay, so let's go ahead and make the list for 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. 40, 1 times 40, 2 times 20. 3 doesn't work, 4 times 10, and 5 times 8. Okay, we'll find the number, the GCF, the biggest one on both lists, and that's going to be 8. Again, my first term is not negative, so I don't need to take out that negative. I'm just going to factor out 8 for my GCF. Okay, well now we do the same thing we've been doing. We look at our variables. First one has an n squared. Second one has 1n, but then my third term doesn't have any n's. Okay, so since all 3 of my terms don't have an n, since that guy doesn't have an n, I cannot take out any n's. The only thing I could factor out was that 8. Make sure to leave yourself a good amount of space inside, because now we need to take all 3 of my terms and divide it by my GCF. Okay, 24 divided by 8 is going to give me 3. couldn't take out any of those n's, so 3n squared. Negative 24 divided by 8 is going to give me negative 3 with 1n attached. And then negative 40 divided by positive 8 will give me negative 5. And we are done. Okay, so that was one where we had 3 terms. They all had a GCF. We divided it out to see what was left. Awesome. Okay, so let's try one more with 3 terms. Alrighty, so my leading coefficient, the one in front, does have a negative. So I'm just going to go ahead and automatically take out a negative. Okay, but now I'm dealing with 3 numbers, 45, 63, 27. 45, 63, and 27. Okay, so for 45, I have 1 times 45, 3 times 15, 4 doesn't work, 5 times 9. For 63, I have 1 times 63, 2 doesn't go into it, 3 does. Let me just get on my calculator here. 63 divided by 3 will give me 21. 4 does not go into it, 5 does not go into it, 6 doesn't, 7, 63 divided by 7, I think that's 9, 7 times 9. Okay, and we're done for 63. And then 27, 1 times 27, 2 doesn't work, 3 does, 3 times 9, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 does, so we're done. Okay, so out of all 3 of these lists, find the biggest number that appears on both. Okay, I usually start with my biggest numbers here. And I can see that on all 3 of my lists, my biggest number they have in common is 9. Okay, so I'm going to take out that negative 9 for my GCF. Okay, but now we need to look at our variables. Okay, first term has 7 x's. Second term has 6. Third term has 4. Same rules apply here. Just take the smallest amount. Out of 7, 6, and 4, 4 is my smallest amount. So I can take out x to the 4th. Okay, let's figure out what's left inside. Okay, we need to take each one of these terms and divide it by our GCF. Negative 9x to the 4th, negative 9x to the 4th, and divided by negative 9x to the 4th. Each one gets divided by that GCF. Okay, here we go. Negative 45 divided by negative 9 gives me positive 5. 7 x's, taking away 4, dividing out 4, will leave me with 3. Next term. Negative 63 divided by negative 9 gives me positive 7. 6 x's, or x to the 6th power, dividing 4 of those out will leave me with 2. And finally, my last term, negative 27 divided by negative 9 is going to give me positive 3. I had 4 x's, I took all of them away. I divided them all out. So we are done. Awesome. Okay, so we just reviewed factoring using the greatest common factor. Remember, the greatest common factor is always out in front. What's inside our parentheses is what we get when we divide out our GCF. Okay, so now for our new concept for today. We are factoring by grouping. Okay, so you'll notice that all of these polynomials in 7 through 10 have 4 terms. Okay, so we are going to factor by grouping. Okay, which again, we defined it up at the top, is just splitting the polynomial into groups in order to factor. Okay, so since we have 4 terms, all 4 of these terms don't have anything in common. I can't take out a GCF out of all 4 of these terms. Okay, so we are going to split it into 2 binomials. I'm going to take my first 2 terms. That's my first binomial, so I'll only factor those 2 at a time. And then I'll take my next 2 terms and factor those 2 at a time. Okay, so I'm going to go ahead and factor these guys first. So out of 2 and 3, they do not have a GCF besides 1, and 1 doesn't change it. Okay, so the only thing I can factor out here are my K's. So if I have 3 and 2, remember, take the smaller amount. The only thing I can factor out from those first 2 is the K squared. It's the only thing they have in common. Okay, now we figure out what's left from this first binomial, just the first 2 terms. Okay, well, couldn't divide that 2 by anything. But if I had 3 K's and I divided out 2 of them, then I have 1 K left over. Okay, now I have -3, which I couldn't divide by anything, but I divided out all 2 of those K's. So we're done with my first binomial, or the first 2 terms. Okay, so now I'm going to do the same thing for my second term. So out of 10 and 15, okay, maybe we can think of this without even giving ourselves a list. My GCF of 10 and 15, the biggest number that I can divide both of these guys by, is +5. Okay, and make sure you do put that +5, because this technically is an expression, what we're doing here. Okay, well, since my first term has a K, my second term doesn't, I cannot take out any K's for these second 2 terms. So now I just figure out what's left over. 10 divided by 5, my GCF, will give me 2. Couldn't take out that K, so the K is still attached. -15 divided by 5 gives me -3. And we're done with our second 2 terms. Now here's what I want you guys to notice. Okay, you should always get a piece, a factor that is exactly the same. 2K minus 3 and 2K minus 3. Well, this becomes 1 factor. 2K minus 3. Our second factor is whatever's on the outside. Okay, so then I have K squared plus 5 becomes my second factor. And we are done. Factored by grouping. Okay, so you're basically splitting it into 2 binomials, factoring each of those binomials using the greatest common factor. You're going to get 2 factors that should be exactly the same, 2K minus 3, 2K minus 3. They become 1 of your factors. Your other one is what's left on the outside, K squared plus 5. Okay, so let's go ahead and try that again. Number 8. So I'm going to split this into 2 binomials, my first 2 terms and my second 2 terms. Okay, I'm going to factor my first 2 first, just pretending that this is a binomial. Okay, I only have those 2 terms. Out of 21 and 7, I know, in fact, I think 21 can be divided by 7. Yep, it's 3. So the biggest number I could divide both of those guys by is 7. I can factor out a 7. Okay, now look at your variables. I have 3 x's here, 2 x's there. Take the smaller amount, which would be 2. So for my first 2 terms, I can factor out 7x squared. Let's figure out what's left inside. Okay, we take both of our terms, divide by the GCF. 21 divided by 7 is going to give me 3. I had 3 x's here, but I divided out 2, leaving me with 1. -7 divided by +7 is -1. I had 2 x's. I divided all 2 of them out, so no x's attached. And we're done for our first 2 terms. Now let's look at our next 2 terms. 15 and 5. Okay, so here's what you always want to check. Can your smaller number go into your bigger number? Meaning, can I take 15 divided by 5 evenly? Yeah, I can. That would be 3. That means 5 is my GCF. Okay, so I'm going to take out +5. +5 because remember, the first guy wasn't negative. We're using the same rules that we've been practicing. First term has an x. Second term does not. So I cannot take out an x. I just need to figure out what's left inside now. Okay, we figure out what's left inside by dividing each term by our GCF. 15 divided by 5 is 3. I could not divide out that any x's, so we're still left with an x. Negative 5 divided by positive 5 is negative 1. No x's attached. Okay, and there we see, because we're not fully factored yet, there we see that 2 of our pieces are exactly the same. 3x minus 1 and 3x minus 1. So remember, those ones become one factor in your final answer. The other factor is what's left on the outside. 7x squared and plus 5. And now we are factored. Awesome. Okay, let's keep practicing. Number 9. Okay, split it into 2 binomials, just 2 terms. Okay, so I'm going to focus on my first 2 first. Okay, so just pretend those guys aren't even there. Okay, so out of 12 and 20, you might need to think about this. I know 2 can go into both of them, but is there anything bigger than 2 that I could divide both of these guys by? Okay, I can divide 12 by 4, and I can also divide 20 by 4. 12 I could divide by 6, 20 by 5. Okay, so I think 4, in fact I know 4 is our GCF. Okay, for 12 and 20. Now look at your variables, m cubed and m squared. Take the smaller amount, that'd be m squared. Okay, let's figure out what's left inside when we divide each of our terms by our GCF. 12 divided by 4 is 3. M cubed, dividing out 2 of them, will leave me with 1 of them. Okay, now for my second term, 20 divided by 4 is 5. I had 2 m's, I divided them all out. So I'm done with my first 2 terms. Okay, now let's look at my second terms. Ooh, okay, little key here. My first term right there for my second 2 is negative, so go ahead and just take out that negative. Okay, 15 and 25. Well, I know that the biggest number I could divide both of those numbers by, biggest factor, greatest common factor, is 5. Okay, so I can divide out a 5 from both of those terms. Now I look at my variables. First term has an m, second term doesn't, so I cannot take any m's out. Now I just figure out what's left inside. Okay, now we need to divide negative 15, that was a negative, right? Negative 15 divided by negative 5 will give me positive 3. Couldn't divide out that m, so we still have the m attached. Negative 25 divided by negative 5 gives me positive 5, and no m's were attached. Okay, we're not done here. It has to be fully factored, but we do see that 2 of our pieces are exactly the same, 3m plus 5 and 3m plus 5. That becomes one of our factors. Our other factor is what was on the outside, 4m squared minus 5. And now we are fully factored. Awesome. Okay, let's do this one more time. Okay, so I have 4 terms here. I'm going to factor by grouping, so I'm going to split it into 2 groups of 2 terms. I'm going to look at my first 2 first. So out of 24 and 30, and you're more than welcome to make a list with these, like our little T-chart lists, okay? But 24 and 30, I know that the biggest number that I could divide both of those guys by is 6. So I can take out 6 from both of those guys. Now I look at my variables, k3 and k squared. Okay, take the smaller amount, which would be k squared. There's my GCF out of those 2 terms. Now I need to figure out what's left inside. Okay, divide each of these terms by your GCF. 24 divided by 6 is 4. 3k's dividing out 2k's will leave me with 1k. 30 divided by 6 is positive 5. 2k's dividing out 2k's leaves me with no k's. Awesome. Let's look at our second two terms. I'm looking at 20 and 25. My GCF, the biggest number I could divide both of those numbers by, would be 5. And it's a positive 5 since the first guy is positive. Okay, first term has a k, second one doesn't have a k. Can't take out any k's. So now we just figure out what's left inside. 20 divided by 5 is 4, with that k still attached. 25 divided by 5 is positive 5. Okay, and we're not done all the way, but again, we do see that two of our pieces are exactly the same, 4k plus 5 and 4k plus 5. That becomes our first term. Our second term is what's left. And now we are fully factored. And there you go, factoring by grouping.